Brett Nelson. I'm a professor with Conestoga College, part of the School of Workforce Development. This is a video in a series that we've created to help students work in a program called Jaamsim. This is a discrete event simulation software that lets you model some fairly complex processes. In my last video, I showed some of the basic ways to model process elements. And in this video, I want to go a step further and show some of the little more complicated ways of introducing some realism into your model and just some variations on the simple process blocks. So one of the things that I want to talk about first is this notion of timing. If you recall in the last video, you have these entity generators which are introducing product or customer orders or people, whatever it is, into your model. And we set the inter-arrival time before as just a constant value, like every 30 seconds or every few minutes. And although that's ideal, where something shows up at a constant rate, that's rarely realistic. And so this idea of allowing some variation in the timing is useful. The way to do that is under the probability distributions menu. There's a number of choices, so I'll just show you a few of them. There's a uniform distribution, a normal distribution, another one might be a Weibull distribution, for example. So you can see or continuous. So in a uniform distribution, you're just saying what is the minimum and what is the maximum, and it will introduce product somewhere between the minimum and the maximum and sort of evenly distributed. Okay, a normal distribution I think is a good one, and the one that I'll show you in a second filled out. And the Weibull distribution, if you have some sort of skewed kind of timing where most people arrive in the morning and then the business tapers off over the course of the day, and then maybe there's a peak in the middle of the day, something like that. So you can define different characteristics, choosing different kinds of distributions. So for this model, I've chosen just to use the normal distribution. And so you define a minimum value, I guess a minimum value. So entities will arrive no less than this rate, a maximum, a mean, and then you can define a standard deviation. So I've set it up so that on average, parts will arrive every minute, but it could be as soon as 5 seconds, it could be as late as 2 minutes, with a standard distribution of 20 seconds. All right, and you don't connect this normal distribution to anything, right? There's no arrows. You can see I've got my connections or the entity connections and links shown. So there's no link to this. It just exists in your model. And then that allows you to name it and use it for anything else in your system. So in my entity generator here, under the inter-arrival time, instead of typing in just a constant, if you use the pull-down menu, it recognizes that this normal distribution is available as a time element and can be used in the model for timing. And so what it does is every time the model needs to interpret the timing for the entity generator, it will pull a value from the normal distribution. So you get a nice distribution of times through that spectrum. Under this generator, I just wanted to show you that I did a little bit more. I used the input builder here, which allows you to build some expressions. And so I've used this normal distribution in an expression. And I just wanted to show you just a very simple one, and you can take it from there. So in square brackets, I've said normal distribution 1. And actually, if you, in this editor, once you hit the left square bracket, it's going to show a list of entities that are in your system. So I chose normal distribution. Sorry, yeah. So normal distribution. Then if you hit a dot, it Now we'll call up a list of the attributes that that thing has. So in this case, the value is what we're looking for. Right? What has been generated by it? So I can just put value, and then I can do any kind of a function. Okay, so Jaamsim will help you build these expressions. So I just said divided by 2, and I accepted that, and it put the single quotes around it, where you can build that in yourself. You can see that you've got a valid expression. It'll show you present value, and it's showing me some number. And if I didn't do this right, it would show me an error message. Okay. So then you can see this should generate roughly twice, well, twice as often, but you can see that it's staggered. Right? There's some randomness to and then sort of natural distribution to the material flow, which is what you want in a more realistic model. Okay. I showed the assembly operation before, where it would just take elements from 2 different queues and put them together. And here again, typically things aren't balanced. It's not always 1-to-1. So very simply here, you have a couple of queues, but in the number required, you can select how many from Q2 and how many from Q3, and enter a value for the entire queue list that you put here, right? So if you pull down, you check your queues, and then you enter whatever the relevant number is for each queue. Then the default is 1. So if you don't put anything in here, then it'll just take 1 of each. So I have the assembly pulling 2 of these and 1 of these to create a sim entity 4. All right. Another thing I think that is useful in a model is the conveyor itself. And I would suggest that you could use conveyors instead of a queue and a server for some processes. So if you have like an assembly line, like something that is where material is worked on as it moves through a line, like for example a paint line or an electronics assembly line, or a washing line, something like that, or a belt furnace, where material just flows through it at a constant rate, then the queue and the server really isn't the right kind of a model, because things don't stack up in a queue and then are processed and then handed on. They sort of get operated on as they move. So although I've been using conveyors just to move material from place to place, I would argue that you can use conveyors as processes. So, and it is whatever you define it to be. So you can define this as the paint line, and I'm just changing the name of it, and now it's a paint line. Points are defined by, let's see if I can just expand this quickly. There's only 2 coordinates, coordinates of the 2 endpoints in x, y, and z, and I'm only dealing in two dimensions, so my z dimension is 0. Okay, if you set this to anything you want, I've just chosen circular arc, it's the one I played with, is I just introduce another point, and I say, well, okay, this 3 point, it goes from 3.6 to 6.8, so somewhere in the middle is going to be 4, and from -7 to -7, so it's along a straight line. I'll make it -7.1 just to be a little bit offset. So I've just invented another point, kind of temporarily created a middle point, and now you can see it's showing up as an arc. And if I select one of the points, a little more difficult while it's running, and then use the control key, and I can drag, and I can make this whatever I want. And you can move, right? You can move these endpoints around and come up with a sort of an interesting shape to your process. So if you have a horseshoe shape to your model, Of course, it's only letting you drag the other end. Anyways, so this lets you make a little sort of visual variation if you want, or you can just leave it as a linear conveyor and a straight pass through. But it lets you add some interesting parts to your model. Okay. Now, this is perhaps the most complicated operation I want to show you. So I'm just going to do a quick reset so you can see all the components that I've got here. So this is a batching operation where there's a load and unload at the front and the back. And so I would use this to model something like a vacuum furnace, or you could even conceivably do it like an airplane. So something that takes material, puts it into some sort of a container, operates on it, or does some thing to this container full, and then removes all the pieces from the container, sends the individual pieces on, and then reuses the container. So if you remember from my last video, we had a pack operation that it just consumed boxes, and the boxes ceased to exist. You just had to define what the box looked like and assume that there was a ready supply. Okay. And you can remove material from the box, move the box somewhere else, and remove material from the box. But that doesn't replicate something like a furnace operation. If the furnace doesn't get consumed, there isn't a ready supply of furnaces. You want a model that that sort of indicates that this furnace is now full. There's a heat treat process going on, and you can't put more parts into it until the heat treat is over. Once the heat treat cycle is done, you've achieved time on temperature, then you can remove all the parts from the furnace, and the furnace is now available to put new parts in. So this is how, at least I model it. I don't know if there's a simpler way, but so the server in the middle is the heat treat operation. Or if raw milk needs to be put into a filtering or a centrifuge or something like that, right? And it takes time to go through that, or it's a brewery and there's a fermentation process, right? So the container is full, something is happening, and then when that cycle is finished, it'll get empty. So this is the something is happening part as the server. As I've said before, every server needs a queue. Okay, so you have this server and queue operation going on here. So I've got mine set as just a very simple 2-minute operation just for demonstration. Okay, then, but what I've done is I started with a add to operation. So the add to allows you to put any number of entities. So in this case, I've chosen 6 entities. A time to how long it takes to put each entity into the container, and what's the container, or sorry, where does the container come from? And so in this case, you have to have a container queue. And so it's a normal queue. I just called it container queue, but it's one of the normal queues that we get from the process options here, right? And the container queue has to have a container in it for this add to operation to work. And so I use an entity generator, which and the prototype entity that it generates is a container. So I've taken an entity container, dragged it in, a standard entity generator, a standard queue. Okay, and in this case, for the entity generator, I have said max number is 1. So the add to operation is going to wait until there are, I think I've told it to put 6. I have forgotten. There we go. I've told it to put 6 entities into the container. So once there were 6, I had a container available. Once there were 6, then the add to operation could put the 6 elements in the container and pass them along. So now they're in the server. So now the heat treat or the distilling process or whatever it is happening. When that's done, then the server passes the container full on to the next operation. So then I've made the next operation a remove from, and it will 10 seconds apiece remove everything that was in the container. Now, let's see. So the simple thing is to talk about the next for containers. So we're used to having this next component. I'm sorry, next component. Pointing to. So where do all the elements go? But in this case, the container is reusable. Like the furnace doesn't get destroyed. The furnace is now available to reload. So the next for containers, I've put the container back into the same queue. So basically, this says the this is basically furnace ready, and if the furnace is here, it's ready to be loaded. And once it's unloaded, it becomes ready again. We'll move back into this ready queue. Okay. The other thing that I've just been a little bit sneaky about is the number of entities to be removed. Now, the simplest thing is to just put the same number here as you have over here. That's easy. I just wanted to show you that there's all kinds of opportunities to use kind of logic statements. So I've, if you're interested, I'll put it up here so you can see it better. So there's this, the word this. So this identifies the name, or is sort of a generic replacement for the name of the entity that is being worked on. And so for me, we need to do this because the container that gets sent through is named dynamically by Jaamsim as it passes through. So I don't know in advance what the name of this container is. This may be the 77th container that's come through. So I can't predict what the name is. But if I just use the word this, that's the generic name for whatever is current. So that I've, again, put dot. And so the sub attribute that I'm looking for, I'm not just looking for this queue, this element, I'm looking for this container. And then within that container, I'm looking for the count. So how many pieces are in the container? Okay, so when I have that set as the number of entities, then the remove from will remove however many pieces are in the container, regardless of how many that is. So, like I said, that's a complication you don't need to do. If you know that it's always going to be 12 pieces, just unload 12 all the time. It's you don't have to unload the whole container. You can also remove some of the load and put the whatever the container is back into the queue. Then the add to operation will just continue to add however many you've programmed to put in and pass it on. So I'm not sure if you had, I don't know, if you're modeling an airplane, you could put the passengers and a pilot and flight crew on the airplane. It flies to the destination and only the passengers come off, but the pilot and flight crew stay on, and the airplane returns to the original airport, or flies back to the airport, and so the first time you load crew, but from after that you don't load crew anymore. So there's all this kind of logic that you can build in. Okay, but that gets you started. All right, I think I showed this last time, but when you're putting things in containers like this, the default is a maximum per line of infinity. So basically, the floor can contain an infinite number of entities. So I find it's pretty nice to change that to some smaller number. So in my case, I only want 3 across, and then this defines how many rows you can put on, and I leave it at infinity because if I set it, it's only a graphic limit, and if I had 100, if I was making a mistake and I was trying to stuff this with 100, it would only show me 2 layers. It wouldn't show me the rest. It doesn't actually stop them from being loaded, as far as I know. right? So I do just, I constrain how many are shown across, and I don't constrain how many are shown high. And that way, if I have a problem with my model, I'll still see it. Okay, I think that's all I wanted to show you there. And then, last but not least, we're going to do a pack and ship. So I showed you this before, very simply. Queue to receive the materials, a packaging operation that's, in my case, going to put 12 in a box, or whatever this container is, and pass the container on to the customer. So one thing, again, I think I may have shown the last time too, is with this container, under the format option, I currently have it to show the entities. That's the default, to set to true. So as the material comes in and gets packed, and so when there's enough, it'll pack them. As you can see, you still see all the parts even though they're packed, and that's just weird. It's not really a good representation. And they all get sent along. So instead of showing entities being true, I like to have that set to false, right? So you can see now it's consuming them, putting them in the container, but then they disappear, which makes more sense. They still exist, they're just inside the container and they're not visible anymore. And so then the container with the materials gets sent on to the next element. I've also done one thing. You can see this, I've got the container in behind. Normally in a model, the container will show up on top of the processing element, and I think it looks a little bit better to tuck it in behind here. So I just show on this first axis, I put a small negative number, and in 3 dimensions, this probably looks a bit weird, but if I put a small negative number here, then it shows up in behind like this, and it helps again the visualization of your model. Okay, and that's going to be the subject of my next video. It's just to change how the model looks, how you change graphics, and improve the appearance of your model. So if you're interested in that, then please check out my next video. Till then, I hope you have a lot of success in using Jaamsim or whatever simulation software you're using to model your processes. I do think that this allows you to learn a lot more about your processes and do a much better job of representing them than a static value stream map or a whiteboard model or even a Visio diagram. This ability to show the interaction of materials, the flow of materials through a system, to me is much more compelling, right? And this is a great tool to use. My name is Brett Nelson. I'm a professor with Conestoga College, part of the School of Workforce Development. I invite you to check out the programs that we offer. And until the next video, I'll see you then.